Hey, hello everyone. Good morning. Welcome to SNIA Developer Conference 2024. My name is Raj from Samsung Semiconductor. Along with me, Swati, Nehal, and Satish are part of this presentation. So today in this session, we are going to talk about evaluating discovery automation on a large-scale anywhere fabric deployment. How the anywhere fabric deployed can be done on a large scale using the automated discovery automation. So here's the agenda for today. So we'll quickly go over through Anywhere Fabric and the Discovery Controller. What are the automation discovery methods available like CDC and DDC, and how those automation discovery works on a large scale environment when it is deployed on an Anywhere Fabric, right? And when we deploy of the solution, how that impacts on a large scale environment when we talk about DDC versus CDC. Based on our study and experiments, we have a small demo. And with the small demo, we'll have few observation and recommendation. And then we'll go over to the summary slides to conclude. Right? So in the few upcoming slides, we'll go through the concepts and the details of the automation discovery methods. And our main goal is to demonstrate how those CDC versus DDC, when it deploys, how those looks like and how it impacts on a scale environment. So this is the first slide which talks about Anywhere Fabric as a high level and what are the discovery controller. So as we know, Anywhere Fabric stands for non-volatile memory express over fabrics, and Anywhere Fabric basically extends the capability of NVMe over the network's fabric environment, right? So we have Anywhere Fabric enable NVMe commands to transfer the data movement between the host and storage over the network subsystems fabric. So basically, when a host wants to connect to a storage subsystems, we see there is a ways that required to standardize, and we have several automated discovery mechanisms available in the industries to simplify the process of discovery. So we do have IP-based fabric transport, which require each host to configure to connect to the storage subsystem using the discovery controller. And in pretty much in all the sessions, we'll talk about the discovery controller. So what is the discovery controller? Discovery controller is a single place where the single location where all the NVM subsystems interface allowed for the discovery, right? So it basically simplifies the process, and the discovery controller resides on a storage subsystem. This is the way that host requires and gathers all the information for doing the discovery from the host sides to connect to the storage subsystems. And it basically gives ways for storage provisions, and implementation can be basically on the like configuration, the host files on the OS or the different ways. In traditionally, normally administrator mostly configure the individual discovery controller on each host using the discovery command. So using this particular command, we discover for a particular IP-based discovery controller using a particular port. And when we think about a scale environment where the 1,000 endpoints where the host and subsystems want to connect to each other, it's a very tedious process and very challenging for a particular host to connect to the each storage subsystems. And we can kind of talk about a scale environment where hundreds or thousands host and storage subsystem wants to connect to each other, right? So we see the challenge here where the limit is a scale and the interop of the IP-based Anywhere Fabric solutions, right? So in this particular diagram, so what we just speak about how the traditional way of implementation the Anywhere Fabric. So the diagram shows the host on the left-hand side, and we have a storage subsystem, which is NVMe target. And both the sides the called as endpoints, and both the endpoints are connected with the network. So when a host query to a discovery controller using configured IP, in returns for a host query, host find the discovery login page, and the discovery login page has the information about the network address, the NQN, which is the NVMe qualified names, and using those information, which has the log page information, host connects to the IO controller for doing the further IOs on the. So this is the manual way where the host and subsystem connect to each other. And the challenge what we see here is each host to configure and connect to a particular discovery controller. And it's very tedious process when we talk about manual here. Right. So as we see about that, we have the automated discovery methods identify, which basically new functionality described in the technical proposal 8009 and technical proposal 8010. And this is technical proposal defined by the NVMe Express organization. So it describes about how we can do the standardization and scalability automated discovery process for a particular IP network. So when we talk about technical proposal 8009, it associated with the DDC, and the proposal 8010, it basically associated with the CDC, which is Centralized Discovery Process. So as an overview, DDC provides the information about the subsystem interface using the MDNS, which is multicast DNS. Using the DNS, it basically allows host to discovery and connect the storage system without needing a centralized way of system available, right? So in terms of when we talk about CDC, it gets all the information aggregated on a single place, and it is a lot more easier process when a host wants to connect to the storage system and vice versa, right? And we can think about as if the fiber channel connection have a SAN A and SAN B. So it gives the ways, the authorization for a host to talk only to the storage subsystems, right? And that way it provides the security. And the additional thing is, whenever there is a host and additional targets available in the network, it's dynamically add those endpoints to the network without doing much reconfiguration. So it gives a very simplified process and gives a very advantage when we talk about the administrator managing the large host and subsystems connected. So in the DDC, mainly we will have two components which helps to simplify the process. One is the multicast DNS, and the another one is DNS service directory, which is DNS SD. So in MDNS, which is multicast DNS, it's basically sends the information to the network and allows all the devices on the local network to discover each storage subsystem without needing a DNS. MDNS work with the DNS SD service directory to basically advertise and discover the services on the local network, and it announces all the devices and NVM subsystems available on those particular discovery controller, right? And this is how it sends the information to the network, and host can connect using those information to a particular targets. So this is the same diagram which we are going to use when we compare the DDC versus CDC. So here are the steps that we work on the DDC environments, and the storage and the host is available on the sides. So via MDNS, host and subsystems discovers automatically. There is no need of manually providing the IP from a host for a particular discovery controller. So when a host automatically sends the command to the DDC at a given IP address via MDNS, and once we have the information, storage admin can provide the namespace to a particular host NQN. Once we have all the information, basically host receives the asynchronous event notification, which provides that I have all the information, and it retrieves the list of IO controller, and all the subsystems storage devices connect to that particular IO controller and do the further IOs. So here we see the challenge here, right? So all the host is visible to all the targets, and all the targets, which is basically storage systems, can visible to the host. So the challenge here is, since we go to a scale environment, when we talk about 100, 500,000 systems altogether, it's a very difficult and challenging job for an administrator or any particular way to manage the storage and subsystems when we try to connect between each other. So this is a slides talk about the high level advantage and the limitations on the DDC. It's a more simpler and straightforward way to implement, and it works very well when there is a manageable host and subsystems on a particular smaller network. And since we don't need a centralized way of discovery to find out the host and the storage, it reduces the additional infra to deployment on this particular environment. When we talk about limitation, as we know that all the host and subsystems are visible to each other, it will be very difficult to work on a complex network environment, and very difficult for a managing and configuration from an administrator perspective. Where is the CDC comes into the picture, where it takes the advantage of finding out automatically and simplify the discovery process when we go through the CDC in the upcoming slides. So as we discussed about the direct discovery, we mainly talk about the discovery information, right? So what consists of the discovery information is basically when we have the DDC connected, right? It has multiple devices, probably say 20, 30 devices. In this particular picture, there are 6 devices. So each device has a significance where it says NVMe subsystem 1, 2, 3 up to 6. So all those respective subsystem will have the log page entry, and those consolidated log page entry for the subsystems can be discovered through the discovery subsystems. So all those information, when it is available, it will be floated around the network. And since all the hosts can visible to the storage and vice versa, we can see the discovery process will be carried out with lot of networks, and it will be very challenging for optimizing the bandwidth in the network environment. So this is a graphical view where we can see the full mesh network, and just right with the 5 host and 5 storage system connects to each other, but it's very difficult to manage with just having the 10 endpoints here. So basically what we are trying to say is, on a scale environment, DDC will be challenging for the host and connecting the storage subsystem in a network mesh environment. So in the upcoming slides, we'll talk about CDC more in detail. So TP8010 which is basically the centralized process of discovery controller. It basically simplifies and enhances the discovery process on a much more larger complex environment. These are the following key aspects that we do when we do the discovery using the centralized process. It aggregates all the information of the discovery from the both host and storage subsystem and reduces the administrator overhead. Since we do the discovery automatically, there is a less chances of having the error, because everything done automatically. So there is no need of manually doing the configuration and reduction of risk of errors. CDC supports the zoning and security. So when we say it supports the zoning, it can be defined by the administrator which host to be allowed to visible for which storage targets. We can think about the SAN A, SAN B, where the limited host or the authorized host can see a particular storage subsystem, not all. So this way we can control the way that how host can connect to a target and a particular CDC environment. And similarly, when a host and storage subsystems adds into the environment, it dynamically discovers those entries through the registrations ways mechanism, and we don't have to do any significant reconfiguration on the host side. So this is the same diagram we have used for the DDC. However, in the CDC, we have the CDC service running in between the network. So we can see CDC can be it's a kind of a piece of software which is running either on the virtual machines or a particular host, or either it can be embedded on a network environment. So CDC, the main purpose is all the host and the storage subsystem should be having the seamless connectivity to work with CDC. Since now the CDC service is available in the network, all the host and subsystem discovers automatically, and it registers the discovery information without needing any manual effort here. So the best thing is now you have all the information registered using the CDC, and CDC is the single point of contact for any time when there is a connection to be established between the network. And now administrator can go and do the zoning. So only the authorized host can connect to each other and look at the storage subsystem available in the network. Or there is another way, instead of doing the manual zoning, once the storage admin provides the namespace to a particular host NQN, the zoning will be done automatically, and that particular zoning called a subsystem based zoning, and that can be sent from a DDC to the CDC, so that you don't need the manual configuration zoning to be done, right? So either way, if once the zoning is done, the host will kind of have received all the information after zoning, and it sends the again the AEN asynchronous event notification to get the log page and try to connect to the IO controller which is available on the target side. So here we all see here now you don't have the visibility of all the host and storage subsystems available in the network. Only a particular host which is allowed with the sense of zoning, only those hosts can be discovered via the storage network. Right? So now, since we look at the centralized discovery, typically this is the diagram that we can look at it. So now the CDC is there. You can see here. Right. So there is a CDC, and all the host and the NVMe subsystem information is aggregated on a single place. And anytime a network to be established between a host and subsystems, storage subsystem, only that particular discovery information will be processed in the network, instead of like you have all the discovery information floated around in case of DDC. So it's a very simplified process when the CDC is the single point of contact, and whenever you want to connect to a particular things, only those discovery information will be floated, and there is a significant reduction of the packets going to the network, and lot of bandwidth of the network to be utilized in some other way. So this is the diagram for the scaling of the CDC. As we talked about scaling the environment, CDC can be much more useful because it has the aggregated information in the CDC, and we don't have the visibility all the hosts connected to the storage system, which will be having a only CDC floating for all the point of contact for all the information to be. So this is the network trace that we have taken from the Wireshark when the automated discovery happens via network, and there is a MDNS query and response to be done while doing the establishment and via doing the broadcast of message that who I am available, and you can probably connect using the available network, right? So we can see here in the it is probably the MDNS and the destination address, and now it says the MDNS, it's a query which is basically tries to go and discover the look for the discovery services over the network via MDNS. So there are two possibilities when this happens. One is when the host is kind of available after the storage system comes online, and there is another method which comes as a probe and response when the host is already available and storage system comes online later on. So here we just captured about the discovery which happens when a host comes online and the storage is already available, and this is the response when we get from the MDNS query, and in returns of the MDNS it look forward for the NVMe discovery. So here we can see the NVMe this as in one of the discovery it looks for it, and here since the protocol is TCP, we provide the information of the TCP network address and all the end-to-end which is required for the host to establish the connection. So from the network trace, we can identify which query to respond from which host to the targets. And if there is an issue, we can kind of look at it and find out some of the high-level information from here. So now, since we talked about manually versus automated discovery, in the automated discovery, we did talk about DDC and CDC. So at the very first diagram, we saw that there are 3 steps involved from the host and storage side. You need to have the IP connection, provision, storage, and discovery and connect, right? Versus in the automated discovery, just the one step, which is storage provision to be done. So we can see the potentially we need 3x more steps when we connect via manual compared to the automated way. And when we talk about the scaling subsystems, basically manually discovery will not be viable when there is an increase of host and storage subsystems in the network. So we'll go through the demo in the next slides. The demo covers the 2 scenarios. One is basically when the single host wants to connect to multiple subsystems using DDC, and we have when multiple hosts try to connect to the multiple storage subsystems using IP fabric network. So here on the top, so we have 4 screens here. So on the top 2 windows, we have the 2 targets which has the NVMe subsystem, and the bottom 2 screens are for the host which tries to connect the discovery and with the NVMe subsystem of the target connected here. So this is the target one, which has the 8 devices connected. Okay. So we see here the 8 subsystems connected to the target one, and it publishes using the AWI daemon. So AWI daemon is basically runs on the Linux host, and when we try to publish the NVMe target subsystems to a network via AWI publish command, it uses the MDNS and publish all the subsystems to the network. So similarly, we have another target also consists of 8 devices, and again we kind of using another IP, a particular 8 devices, and then we see that using the Hawaii publish, we can all the 8 devices also publish to a network. So these are the two targets connected, and now the third window on the bottom left, which is the host, and this is a single host which is trying to connect the discovery and list the NVMe subsystems which is published from the target over the network. So it is basically trying to attempt to discover all the 16 devices including both the targets, and it shows single host having 2 targets which is basically 16 target subsystems, and we see typically it takes around 2 seconds. It's just for the reference that we are talking, we are not claiming any numbers. However, in the fourth window, which is the right bottom side, here we are trying to connect all the 16 storage subsystems using 12 hosts, where compared to in the third window we connected only with the one host, and we see it is doing the discovery and doing the NVMe list of the 16 devices which is connected over the network, right. So here typically we see here it is taking almost 4 to 5 seconds for each host to do the discovery. This is the average time we look at it. So the demo try to explain here. So when we have only 3 endpoints where 2 hosts, single host and 2 subsystems, there is a discovery time, and when we increase the number of hosts and storage subsystems in the network, there is a increase on the discovery time, increase from 2 to 4 to 5 seconds, right. So what we are trying to say from the demonstration here, so as soon as we increase the number of subsystems and hosts, the discovery times will increase because a lot of network packets has to go over through, because all the devices are visible to all the hosts here. Right, so it says from each host, sometimes it takes 4 seconds, sometimes it is 3.6, sometimes it is 5 seconds. So the average discovery time it is around 4 seconds, right. So that is one of the demo that we demonstrated, where we increased from 3 endpoints to probably 12 hosts and 2 targets, which is 14 endpoints. Now in this diagram, we see when we scale environment for 12 targets connected to the 18 host in the left hand side, and we see the discovery time increases significantly to around 30 seconds, 31 seconds, right. And on the right hand side, when we talk about the another host, when the number of hosts increased from 18 to 36, which is almost double, we see the discovery time increases by say 36 seconds. So all the numbers that we are talking here about, so in the previous demo when we say the number of hosts and targets are manageable, so we don't see the significant increments on the discovery time. When we scale the environment in the DDC environment, you can see the significant discovery time from the each host which is trying to connect to the targets has come to 30 seconds versus 30 seconds. Right. So based on the study and the experiments what we have done, we have few observations and recommendations, and these are done basically on the 3 points. One is discovery time, the network congestion, and still if you want to use what is the better way to optimize and use it. So in the DDC, what we seen in the demo, the time increases as soon as the host and targets are connected more and more. So the demo what we see is still DDC can be used on a scale environment, but it has to be provisioned better, and a lot of careful networking has to be done when you want to use DDC still on a network environment. But there is a impact on the overall network, and this is basically due to the congestion, because all the discovery information has to be floated around the network. Where in case of CDC, we probably overcome about those challenges. Though we increase the number of hosts and the subsystems, we probably not see the increase of the discovery time, and even the high volumes in the scale and network environment, it has a single point of contact, and which reduces the significant network traffic and reduces the congestion over the network. However, in the CDC, we still have to do the zoning or the automated way of zoning, so that only those hosts can be allowed to visible to the targets without the need of manual configuration, right? And we do have a tool called NVMe STAS, which is an open source tool, which is available on the public GitHub. And this also helps further to does the discovery of instance, reducing the manual efforts, even though either we use CDC or the DDC. There is one of the challenge that we see on the CDC, which is the single instance if we go and look about running on a network. However, we can reduce the failure mechanism if we deploy multiple CDC instance, and that can be kind of configured in a high availability environment where either you can provide multiple IPs to a single CDC, or you can have multiple CDC instance running on a network for a better resilience. So to conclude the overall discussions which we discussed on the automated discovery, though we cannot eliminate the way if anybody wants to use DDC on a large scale environment, but we need to use the careful planning on the networking side, and the expectation is still if we use on the scale network, the expectation is we see the potential network congestion and we see the increased discovery time. However, in this case of CDC, we see the significant advantages because it reduces the discovery times, even though you increase the number of host targets to say 100 to thousands, it improves the network performance and simplified the management. So definitely with all the benefits, we can say CDCs will be the preferred choice when we talk about the more complex and the scaled environment network on the NVMe fabric deployments. So this is all what I wanted to go through on this session. Yeah. Thank you.
Let's say that you're assigning a namespace to a new host dynamically. How does that work with the CDC to get that exposed to the host?
Okay. So as we discussed, even though if it is CDC, sorry?
You may want to repeat the question. I don't think they have the answer.
Okay. So you want to know how the discovery happens when a particular namespace in the CDC environment from the targets to the host.
When it gets exposed dynamically, the host is already hooked up, it's already connected to the CDC, and then a new namespace is available.
Right. So in the CDC, as we discussed, right, it dynamically, when the host comes online or the storage comes online, it automatically sends the broadcast message via MDNS from a storage that okay, the new entity is available, and those information will be sent to the CDC. So CDC will get the notification that okay, I have another storage subsystem available.
It's already hooked up. This is a new namespace, not a new subsystem.
Yeah. So that's what. So this is how the dynamically it kind of runs the Hawaii. So there is a service which is runs on the host side, which is a stack D and stack C. So what it does is there is a stack daemon which is ST C, right, which is doing the connectivity part, but there is another steps which comes as a finder, which will does the finding of all the new host which comes online dynamically. So using the finder daemon, it comes and checks that okay, there is a new host available, and that publishes through the connection, and it dynamically availables. That is what my understanding. Though we are yet exploring the CDC to implement and explore in our lab. However, we have the DDC done a lot of experiments, but yeah, the CDC is a lot of experiment has to be done.
Will the asynchronous event notifications come from the storage or will they come from the CDC host?
So the always the asynchronous notification comes from the targets side of it to the host, so that it says that all the information is available, and then it goes and connects to the IO controller.
But the reason that the CDC is implemented is it generates the AENs when new information is registered.
Okay, this is probably while I have the knowledge not experimented well, so probably I can go and discuss about the asynchronous notification, how it goes from the targets or from the CDC to a particular host. So that particularly I will take it and look back for that.
Then as a follow-up question, in the H8 situation, does that mean that the targets have to register their log pages with multiple CDCs?
So it depends on the implementation. However, the specification doesn't talk about how you want to implement. It's all about how the user wants to make a high availability on the systems, so that you have the failure and then you have the connectivity to the CDC. But though when we talk about CDC, there will be many CDC instances running on the CDC, like how the fiber channel have the SAN A, SAN B. So various, similarly we have a different CDC instance running inside the CDC itself, so that it will have the configuration on a particular host and storage subsystem. But to answer your questions, that if there is a failure happens in the network, you may need to clone the similar information to another CDC which runs on a different host or a different network entity, so that failures can be looked upon it. But as far as the specification, it doesn't talk about anything how you do the multiple instance running on a multiple host.
You told us open source CDC client. Is there a CDC server available? Is there open source? Or
The NVMe STAS?
not open source? Yeah, that's a client.
Yeah.
So where do we get the server?
Yeah, that's it's just the configurations. Yeah, so there are ways where we have the vendor specific implementation is available. So that way you can go and look about those particular solution if you want to have the ways or dedicated ways to implement the CDC servers, right? Which is probably have to purchase.